Okay guys, in today's video I'm going to be going over multicast vote scan system and how it works. Um, I'll be going over the wiring diagram and the programming. Start off with a simple block diagram here. I'm going to walk through it to show how it works. A multicast system is a system much like a simulcast system where all the transmitters are transmitting at the same time. However, each transmitter is on a different frequency. They're not on the same frequency. That's the difference between simulcast and multicast. They do have a common receive input, and I'll go over and explain how that works. A mobile user out in the field, we're going to start off with an example where they're just able to get into one repeater. When they key up their transmitter here, when they get into the repeater here, local repeat is enabled and is immediately repeating them back. Their recovered audio is sent along the network connection through the IP-223 back to the console, and it is also using the COR indication from the repeater that there's receive activity, and that COR indication is turned into a push to talk, and the receive audio is turned into transmit audio for the other repeaters. So when this one receives, the audio and COR comes down here, and then they're turned into push-to-talks, returning back to the other repeaters that did not hear it. Now, if this same user is heard by multiple, let's say it's heard by both these repeaters, both of them go ahead and locally repeat. Both of them bring their audio and COR back here, and by a physical priority status of which one is connected in which order, the top priority station's audio is then used to repeat back out to any repeater that did not have the receive coming in directly to it. So, and of course, if all three hear the mobile input, all three locally repeat, and the only one receiving the receive audio will be the console. And once again, it'll get the priority, physical priority site that's been deemed the number one site to hear. Now, in the reverse direction, if the dispatch wants to transmit, they have two different ways. They can actually three different ways. They can individually transmit on any individual transmitter. They can also multi-select all three transmitters using the console function to do the multicast, or any combination of the three. Or they can also just use the IP-223 here to essentially backdoor the all three transmit through the IP-223 here. So they have three different ways of transmitting out on the repeaters. I want to specify that this system right here, like I said, everything is basically mechanically tied together so that whatever comes in on one goes out on everything else, and vice versa. This is essentially a poor man's version of this system, which is if you have the ability to have once again the true network connections, where you can use a Codan/Zetron now voting comparator, and they'll actually be able to, if you get multiple hits, they'll be able to judge by the RSSI levels coming in which one is the strongest, and then you can repeat back out that way. And that's one way of doing it, and you can, like I said, and you can control whether you want to locally repeat or not. I like the idea of having standalone repeaters that can locally repeat and are not beholden to being connected to the network to work. I want them to work even if they completely lose their network connection. So, this is the detailed connection of the the relay interface here, and I wanted to go through it real quick and kind of make some comments on some of the circuits here. So let me pull this down where we can all see it, and let me juice it here. Sorry about that. Okay, this is good. So anyway, this is the example of the relay, and each repeater has a relay that represents it back at the central hub. So these relays are triple pole, double throw, and what they're doing is each section here has a different function. So whenever the distant end repeater receives traffic, it engages this relay. So whenever the relay is engaged, it does three different functions. The first function is to provide a ground contact that allows the other sites to rebroadcast through their COR connection. So that's number one, and it also gives a COR indication for the console for the IP-223 to start sending audio packets to the console. The next function that this relay does is it prevents its own site from rebroadcasting. So if you notice that this input here is to the COR input, so whenever this relay engages, it gets connected from 8 to 5 to nothing here, so it doesn't get a chance to essentially engage itself. It's immune from rebroadcast because it's already getting transmitted locally, and we know that by the fact the relay triggered. So we don't want to re-engage it from the other side. The third function that this does is it takes the recovered audio coming from the repeater and presents it as a bus audio for all the other sites to use as transmit in for their repeater connections. So, and this function is repeated. Let me see if I can flare out here. This function is repeated at the other two transmitters, basically the same way. And when I was talking about priority, the top site here has the first connection where if this one engages, it's going to put its transmit audio, its receive audio that it's going to for rebroadcast, and it's going to have priority, and it's going to come over here and provide everything. If this one opts out, the next one in a row here, and it does a daisy chain with these connections, the next one in priority list would be this one. If this one's not engaged, then it drops its audio down and goes to this one to see if it has anything. And this pattern repeats. And down here would be the next connection for if you wanted to add a fourth channel. And that fourth channel can actually be, it doesn't need to be a complete repeater. It can just be a satellite receiver. So that's the other cool thing about this is if you just wanted to put a satellite receiver in somewhere, whenever it received a signal, it would retransmit on all the other transmitters as long as one of the other ones didn't have priority above it. So it's a great way of filling in a little niche spot. And this is all going on what kind of WAN system you have. We're looking at using the Cradle Point cellular system to create our own little WAN LAN to do that. And what I found is when doing that, those connections and everything, that it was best that I use Multicast instead of individual IP addressing, unicasting, because when you're unicasting, if there's something goes on with the other end, it'll refuse to unicast from the from the local end, and it'll be confusing because you don't know why it's not working. Whereas if you set it for the multicast like 226 address, it'll just spray and pray. It doesn't care. It doesn't need any acknowledgement from anything, and it'll just fire every time. So I found that to be a lot easier when I was troubleshooting the initial connections and everything and figuring out which way it was going where. That multicast was the way to go for this system. You can do it unicast, but like I said, if there is a break in the connection between either of the two, they both appear to fail. They both won't respond when triggered on their COR, so just keep that in mind. Okay, the next subject in here, and I will put in, let's put in the jumper settings and the programming. These are going to be really important, obviously, for both the 223 and 224, if you happen to use one of those. The 224 will all be programming instead of jumpers, but I'm going to leave this at the end here, all the drawings up for a few seconds in the video, at the end of the video, so you can do screenshots of each one of them. But just to go over quickly, for the central site drop units, I put in here you got to want to make sure that you're using single-ended audio. We're not, because we're using those relays to route stuff. So you're going to use balanced audio over here at the actual repeater interfaces, but at the central site it's all going to be single. So, and mind all of the impedances because those are important. In the programming for the central site, you're going to just go local mode, one channel, COR enabled. We're not using LAM. No delays, no options. Just absolutely plain Jane. On the line 2 that the console is connected to, once again, no frills, no options. It's going to be in console. It's going to be in local mode. That's an error there. I'll have to change that. And it will be 2-wire operation, and with COR again, no LAM. Repeater interfaces once again, we're going to be doing the balanced audio. So, and that'll do it. I'm going to go ahead and give a demo of it actually working here next. So, and then like I said, I'll put all the screenshots up at the end. So stand by for that. All right, here's a demo of it in action here. I got the 3 repeaters here lined up. Each one is fed by its own IP-223. I have a CSOF console here going on the laptop, and it is connected to the IP-223 down here, and the other half of this IP-223 and this one above it are the matching pairs to these other 3. So up here on my CSOF console, I can do individual push-to-talk for each repeater. I can also do the master push-to-talk, which will go through here and then connect back through all the other IP-223s. So I can do my full multicast. If I come in with a portable, each repeater that hears the portable input will locally repeat, and they'll also send the recovered audio back and a COR indication back to the central hub here. Any one of these repeaters that does not receive the field transmission will get the audio sent back to it the other direction, and a push-to-talk for the transmitter. So that's how it doesn't matter which one they come in. Anyone that is not receiving it will get the transmit from the other side. So I'll give you a demonstration. Right now I have Well, I got to turn the radio on. I have all three receivers enabled. So when I key up on my portable here, all three will receive. They'll all three locally repeat, and they'll send the audio back to the console. And testing 1, 2, 3, 4. So that demonstrates it coming where all the repeaters are hearing the input. Now, if I disable this receiver here, when I key up now, these two repeaters will hear it, and it will use the audio recovered from the primary one here to retransmit now and be able to actually rebroadcast, although it did not actually hear the receiver itself. So when I key up, now I'll get my reverse back feed here on my transmit coming from my IP-223 to go out. So, and that works in any combination as far as any two or one receiver can be out at any time. So, and this system is scalable to where all you have to do is add another channel, is just to add it onto the bus here with the series of each repeater gets its own relay to trigger to introduce its COR as a push-to-talk, and its recovered audio is transmit audio for any other repeaters that didn't get it. You can also hook up to straight satellite receivers so that it doesn't, you don't need to worry about returning transmit audio back that way. They're just meant for niche fill holes where you want the system to be able to hear in that location. It's already got transmit signal going back that way. So, and also up here on the console, you can do multi-select and multicast that way if you had difficulty for whatever reason with your main unit here. So that's the back door for dispatch to continue multicasting. And they can, like I said, individually transmit on one at a time if they need to for whatever reason, for limited activity. So, all right, well, there's your demo of it in action. We'll talk to you soon.